Good afternoon, Professor Teodolo. We speak to your student Ruslana Mejia. In this opportunity, I talk about the two last laboratories based on the compass swing checking. Well, the compass swing checking is a procedure for calculating and correcting the effects of the aircraft magnetic fields on its magnetic compass. The aircraft is taken to a designated arcs where with its service that are normally on during flight or desviation is measured on various heading and connections are applied to the compass. A compass correction card is made if any residual deviation is still left. Well, an aircraft is swing at periodic intervals after a major component change, after a major servicing, or if it's relocated to a significantly different latitude. Um, Maximum accuracy is achieved after the compass swing is done in flight. Um, for the realize of this practice, we checked two important documents in the IAC 43 13 and 1 and the AC number 43 215. Okay. First, once necessary information has been obtained in the basic planning quiz started, we discussed the principal planning. We have the 12 steps, including the class up. Okay. Well, the first procedure. Well, the previously of any step, it's important to have the clean area. The first step is using the digital compass system to perform a compass swing to find a clear area to perform a swing. You want to make sure that the area is free of metal structure that will interfere with the magnetic compass. If there is a compass rose of the airport, that's the same area to use. Verified above this procedure, we proceeded to align the compass located in the cabin with the master compass instrument used for this procedure. Bearing in mind that the first line to the instrument must be aligned with the nose of the airplane, and while the second with the empennage of the same. Okay. Once this alignment was made, the corresponding instrument will execute the position north, east, south, and west in the degrees and 0, 90, 180, and 270. And in the order of effectivity carry out the process, the beast carried a steering bar. Is a steering bar was used, which allowed the aircraft to reach easily towards. We have the value obtained. We have the value. Okay, and after obtaining the value, we use the formula. The NS north and south correction is this. We replacing the values obtained in the table here, obtained at minus 10.5 grades. Okay. The value obtained is added to the number of degrees represented by the north position, resulting in 349.5 grades. Now the aircraft will be taken to that position value that using a special non-magnetic tool, it will be calibrated and corrected at 0 grades, which is the true position. Okay. Now we have the east and west correction. We have the form. Okay, we have the form. We have the form now here. Okay, and the final result of this is 23.5 33.5 grades. Okay, fine. So value obtained is up to the number of degrees represented by the east position, resulting in 113.5 grades. Now the aircraft will be taken to that position and be using the non-magnetic tool will be calibrated and corrected at, at the position of est, which is the true position. Okay. Once the calibration process was completed, we have the verification measurements. We started using the different values in degrees of position, so as to perform that the calibrations were carried out correctly. To confirm these obtained measurements must be not exceeding a margin of error of 2.5 degrees of the theoretical value granted. Next, the comparison table. We have the comparison table. We have the value. Okay, we can observe the values, the compass correction. And as can be observed, if most measured values that the error exceeds be more than 2.5 grades, the theoretical value observed. So it was determined that the interior process was performed incorrectly, and due to the fact that the executed process was erroneously deployment, and what is sought to is to be carried out objective of calibration the instrument in an optimal way. But if it was carried out again, on the other hand, it is important to mention that the learner in charge of the work forget to leave watches on cell phones outside of the work area. So it was determined that these aspects interfered with the taking of measurements, the measures. Okay, we have the second process. For the second, is the same steps, only we carry out as in the process. That none of the people in charge of the work have any type of component that affect the taking of measurements. The value obtained, we give the value obtained, and we repeat all the steps of the first process. We have the north and south correction is a 7.25 and 25 grades, and the east and west correction is a minus 12.5 grades. Well, this value is cited to the number of degrees represented by the est position, resulting in 77.5. Now the aircraft will be taken to the position and value and be using the special tool. Special non-magnetic tool will be calibrated or corrected at the correct position, which is the true position. After carrying out the calibration, the verification process was started, taking into account the 2.5 grades error tolerance between the measurement value and the theoretical value. The comparison table, we have the comparison table, the compass correction for heading. We observed, as can be seen in the values shown in the table above, this complete with the margin error previously established, which determined that the second test, the procedures and calibration performed were carried out properly, thus ending test laboratory. Finally, the conclusions. As it could be observed from the first test performed on the instrument of the aircraft and according to the data obtained, it was determined that this was completely calibrated. In addition to the two processes we carry out, as the result for the value calibrated in the first process exceeded 2.5 degrees, this error in the first procedure was generated because the team in charge had magnetic components in their actuator. However, the second test was carried out successfully, since the composition of data obtained showed that all the values measured in the comparison of the theoretical values granted fully the margin of error previously established, concluding that all the calibration were made successfully because, as you know, the compass swing is a process of swinging and compensating an aircraft compass be determined and reducing the deviation and the deviation coefficients on the recording the residual deviation. It was concluded that the calibrations were carried out successfully in obtaining the values within the range of the error margin to 2.5 grades of degrees, determinate that the functioning the test to the remote compass system going in the aircraft form an essential part of the maintenance process with the respect of indication instruments remote, corroborating through the comparative measurements and determination of the variations theory taking into account the operational limits of the system according to the appropriate manual or the documents, in this case the EC, okay? Detecting faults and the possible solutions, okay? And the possible solutions. Okay, and thus maintaining the awareness of the aircraft is regard to this system. If you are in a clear area are still encoding compass accuracy problems, check the mountain hardware for the compass and the hardware of the vicinity of the with compass and ensure it is brass and not ferrous. Other thing to be aware to are magnetizing control yokes, structural tubing, and improper inverted electrical wiring, or all of which can cause unreasonable compass error. When working around a with compass or flux veil, use only non-magnetic tools. Brass and screwdrivers are preferable, especially when making adjustments. Never use any magnetic type tool when working in the vicinity of the wet compass or flux veils, as this have an adverse effect on the compass system. This is all for this opportunity. Thank you for listening and watching.